MATLAB contains a lot of functionality for different types of data, and what I want to do is I want to just try and explain some of those data types because we'll have to use them when we start programming. So I'll say this before I go any further. MATLAB, although it has a lot of functionality for these data types, we often don't have to worry about them because there's a default data type that we always end up using that for most cases is fine, and that's good enough. But I do want to explain what these data types are because they're common in all programming languages, and especially if you use a programming language like C or C++, there's a lot more reliance on you understanding what different data types are, and they could mess you around a lot if you don't understand what the type of data type your variable is. So with that, let me just start off with the first data type, and that is integers. Right, so integers are whole numbers essentially, and you can get them in two types. So the one is, I'm just typing out everything in the command window so that you can read it, but the one type is unsigned integers. And unsigned integers are just positive whole numbers essentially. So 1, 100, you know, 169 are all whole numbers, and they're unsigned integers. And then you also get signed integers, and signed integers can be -2. So -1, -1, -169, positive 169 is also a signed integer, and so signed integers encompass unsigned integers, but the difference that computers make is that unsigned integers can normally cover a wider range of numbers. So what I mean by that is, if you go onto the web and you look for MATLAB data types, then I'll put this on the website, but you can go and you can try to find a link to integers, all the integers that MATLAB supports, and if you look down, you'll see that MATLAB supports a whole bunch of different integer types. So I can get an 8-bit signed integer, I can get a 16-bit unsigned integer, 64-bit unsigned integer, and all of these are just ways of representing whole numbers with respect to a certain range. So why do we want to have a different range? Well, turns out that if I want to represent numbers between -2 to the power of 7 and positive 2 to the power of 7 minus 1, then that just takes up 8 bits in memory. So 8 bits in memory is sort of like the smallest amount of memory that MATLAB can take, but then that means that I can only represent a certain range of numbers. If I want to have something bigger, then I have to use maybe a 16-bit, a 32-bit, or a 64-bit. So when you look on your Windows computer and you've got like a 64-bit machine, it's really related to the memory type that Windows is using. And it's the same thing that's happening in MATLAB and all computers. We're trying to represent numbers in memory, and that memory takes up space in your RAM, and so we must try represent them with certain numbers. If you look, so this is just something interesting. If you look, all of these numbers are related to 2 to the power of something, and if you can guess why, you'll realize that 2 is very important because all computers are binary, right? They either have an on state or an off state, and so all of the logic, all of the mathematics and everything in MATLAB is related to powers of 2. So 2 to the 1, 2 to the 2, and so on. So let's just try and understand what these unsigned integers are. So MATLAB exposes a lot of functions for you to create variables of certain data types. Again, we're not going to use these functions very often. Often we don't actually care because for our needs we don't have to be so specific. But again, if you move into another programming language, then data types are very important, and then you must understand them. So that's why I want to just explain what's going on here. So there's a function in MATLAB called int16. Okay, and int16 will create a variable that's a 16-bit signed integer. So it will represent numbers between -2 to the power of 15 to 2 to the power of 15 minus 1. Okay, and so if I put that into MATLAB, so I say, let me just get rid of this. So if I say int16 of 325, and let's create a variable. So I'm going to say x equals int16 of 325. Then it gives me an answer, x is 325, and it looks like a normal variable. But the difference is that x now is a 16-bit integer variable. The data type associated with x is a 16-bit integer variable. So if I try and do something like this now, I say int 16 of, let's say minus 2 times 10 to the 17, let's say. Let's try to do 17. Then it gives me that number, but if I try to do minus 2 to the 17, just like this in MATLAB, then it gives me a different number. So actually, minus 2 times 10 to the 17 is this number over here. But if I try create a 16-bit integer variable using MATLAB's function, then it spits out this. And this number actually isn't the same as minus 2 times 10 to the 17. This number is actually minus 2 times 10 to the 15. So let me just prove that. It's minus 2 times 10 to the 15. And why is that? Because, well, a 16-bit integer in MATLAB can only have a maximum number of minus 32,768. So that's important, because when we start to use very big variables, or we use very big ranges to represent data, then if we have a certain data type that can only represent certain numbers, then we might be beyond that range, in which case our calculations will be incorrect. So it's very important that we understand the different ranges and what these integers are. So let me just do one more with a signed, unsigned integer. So an unsigned integer is just a positive number. The range is from 0 to 2 times 10 to the 60 minus 1, for instance. Okay. And so if I try to do uint 16, so u in this case stands for unsigned. And let me do minus 2. What's going to happen? Well, minus 2 is beyond the range of an unsigned integer, so if I put it in, it gives me a 0, because again the universe of an unsigned integer 16-bit is excuse me, from 0 to 2 times 10 to the 16 minus 1. So that's integers for now. Next we'll do floating point numbers, and I'll explain other data types. But again, see these discussions as me just trying to get across the different data types that computers use in general. MATLAB has these data types, and you can use them. We often don't, but it's important that you understand that computers represent data with different data types, and those data types all take up different types of memory. And if you really want to make really good programs, really fast programs, you need to understand these different intricacies in data types.